Welcome back. Section 6-6, inverse trigonometric functions. Recall the function fx equals sine x and its graph. So sine x is this uh, oscillating function. Sine at 0 is 0. Sine at pi over 2 is 1. Sine of pi is 0, and so on and so forth. Note that this function is not one-to-one, because you look at the horizontal line here in red. It meets your curve at several points. In fact, it will continue to meet your curve at infinitely many points on the right and on the left. In other words, it is not a one-to-one function. But we could restrict this function to a certain domain. Negative pi over 2, that would be here, to pi over 2, that's here. So the picture now, the sine function on this restricted domain is the lowest height at -1, the highest value is 1. And you have this function is now, the restricted function is 1-to-1. So since this restricted function is 1-to-1, you can define its inverse function. So recall f inverse of x is y if and only if fy is x. So we define the inverse sine function, also called the arc sine function. Sine inverse of x is y if and only if sine of y is x. So notice the sine function domain is negative pi over 2 to pi over 2. Sine function has domain negative pi over 2 to pi over 2. Sine function here has range -1 to 1. So sine is negative pi over 2, closed interval, to -1 to 1. Therefore, sine inverse is from -1 to negative pi over 2, pi over 2. So you see the domain of sine inverse is -1 to 1. Moreover, because sine inverse is inverse of sine, on the appropriate domain, sine inverse of sine of x is x. So that x has to be in the domain of sine. Sine of sine inverse x is x. Now this x has to be in the domain of sine inverse. All right. Now let's look for the graph of sine inverse. So notice this is sine. So sine inverse must be a reflection about the line y equals x. So there you go. So arc sine function looks like this. Domain -1 to 1, range negative pi over 2 to pi over 2. Now with this information, let's evaluate tan of sine inverse of 0.5. 0.5 is somewhere here. So sine inverse of 0.5. All right. Likewise, evaluate cosine of sine inverse of -√3 over 2. We may address these questions in several methods. One approach is, notice sine of pi over 6 is 0.5. So sine inverse of 0.5 is pi over 6. So you got sine inverse of 0.5. That will be the angle pi over 6. So tan of sine inverse of 0.5 is tan of pi over 6. Tan of pi over 6 is 1 over √3 or √3 over 3. Likewise, you want to find out which value gives me -√3 over 2. Sine of negative pi over 3 is -√3 over 2. In other words, sine inverse of negative square root 3 over 2 is negative pi over 3. You see, sine inverse is inverse of sine. Now, so cosine of sine inverse of negative root 3 over 2 is cosine of negative pi over 3, which is cosine of pi over 3. That's because cosine is an even function. Cosine of pi over 3 is 1 over 2. All right. Now, next we will look for derivative of the arcsine function. We'll continue this in our next video.